because turns out having the information in some sense and abstractions flow from model customization to actually building agentic applications is actually really helpful. So the stack itself contains two parts to it. One is the model toolchain API, which is also known as, I guess, LLM ops. So this includes all the things that are needed to customize a model. It could be fine-tuning, running evals, and it's not just about fine-tuning or just running evals on the model itself, but running evals at an application level as well. And then there's several primitives that you need in order to build agentic applications using not just Llama models, but any other models. So we defined a set of interfaces for each of those primitives that are needed to build agentic apps as well. And memory here just for is more of a general term for RAG, or retrieval augmented generation. That's familiar to you. So we defined the set of APIs back in July, and we just released that as an RFC. And the reception from the community has been great. And it's not only from developers, but also from a bunch of our partners. And last month, or a couple of weeks ago, we launched Llama Stack with a whole bunch of partners. So the way that we did it was, once we defined these standard APIs, we worked with partners to build implementations for these APIs. Just having a standard is not good enough. You need something that people can actually play with. And turns out there are many partners who are really interested in providing these standard APIs. And we worked with a lot of them. And turns out different partners only offered certain capabilities, not the entire stack of APIs. So we said, okay, we'll take a combination of a few API providers that actually work well with each other and build a single package called a distribution. That'll make it so that for a developer, it's just a single endpoint that they have to hit to be able to get all the capabilities of Llama Stack. And we have several partners here, including AMD, that we've been working closely with. So the developer experience with Llama Stack is actually much more straightforward than before. In order to actually spin up a stack, it's just a couple of commands, and you're able to run this internally on your own node, on a single node, or even in the cloud, if you will. But once you have a Llama Stack server or a distribution server running, the developer experience is as if you would have just an API that you would work with. And when you write your code, it's a few lines of code, you're able to actually very easily run it also without really having to piece together multiple tools. And note that even though the interface is very minimal, the actual implementation could be any one of those that I have talked about. Right? And what I showed you here is just on a single node, but then turns out it's a very simple experience even for on-device inference. So I don't know how many of you are iOS developers, but this is fairly minimal for iOS in terms of adding kind of inference calls, and you're able to actually deploy it as an app with on-device inference very, very easily. So with Llama Stack, what we have found is that for developers, we have provided very easy to adopt APIs in multiple languages. It's Python, Node, Kotlin, Swift for iOS apps as well. And for developers, they have a choice of distributions that they can either use that are already provided by our partners, or they can build their own as well, depending on whatever combination that of API providers that they like. And of course, using these APIs and these SDKs means that they're able to get started very quickly and start building applications rather than having to wrangle a lot of the tooling. And for providers, because they're building to a standard, they don't really have to worry that much about having to integrate with like a bunch of other tools that are out there. And a lot of the capabilities that the ecosystem provides, really critical, but at the same time, certain providers may find that that is not where they would like to differentiate. So in those cases, they can just rely on the fact that other providers have built to these standards, and they can just focus on what they want to be really good at. And for the partners that are actually building towards these standards, Meta is investing in providing verification, like providing some level of support, so that when customers want to use Llama models with these distributions, they know that these distributions have been verified by Meta, right? Again, this is all just getting started. There's a lot that we'd like to do in terms of both supporting developers as well as providing partners. And we are also finding that hardware vendors like AMD are able to leverage a lot of these standards so that they can optimize their kernels, or like the work that they do, in order to support providing like really efficient implementations for their customers. And like I mentioned, we're just getting started. Going forward, clearly there'll be more and more capabilities of the Llama models that we will be offering. Longer context length, more paging, as well as like cross modalities, think about speech, voice, video, things like that. And from the Llama Stack perspective, build out like the full set of capabilities that any developer would need in order to be able to use these models. And of course, work with many more partners to make it so that a diverse ecosystem can actually grow with the open source models that we are actually building. So I'll end there. You can scan this QR code, I guess, to learn more about Llama Stack itself. We're building all of Llama Stack in the open. It's on GitHub. And we've seen a lot of traction, even in the last couple of weeks that we have put it out there. We've had like thousands of downloads and thousands of stars on GitHub, which is pretty heartening to see. And yeah, with that, thank you, and have a great rest of the day. Thank you.